So at this point, I will take you through the machine learning project side, where our objective was to develop a machine learning model to predict the risk of heart disease based on various health-related features, and the features are as listed below. So to do this, we imported quite a number of libraries, each performing different functions. The pandas, matplotlib, seaborn for the test and split, and for the decision tree classifier. And just to mention, the reason why we picked on decision tree classifier is because our outcome is binary, and so when the outcome is binary, you can only go with decision tree classifier or logistics regression. When it's continuous, then you can go with the likes of linear regression. And so that's why, since our outcome, our y is binary, that's why we picked on decision tree classifier. So on data processing and cleanup, we did quite a number of process to deal with the nulls. And you will notice for cases where we had classification kind of data, we were replacing with the mode, and for continuous type of data, we were replacing with the mean. Just to mention that. So then we moved on to exploratory data analysis, and these were the columns, generally, everything. And we moved ahead to just see the data types, just info about the data, just familiarizing with the data that we're dealing with, to understand the mean, standard deviation, the minimum, the maximum, the distribution, lower percentile, median, and that. We also went ahead to just visualize some of the variables, like age distribution. You notice that the highest participants were between age 40 to 42. There was none above 70, and most people were between 35 and 65. On our correlation heat map, something interesting we noticed about this is that there are some variables which actually, directly depend on each other. Our main aim really our main target was the 10-year CHD, 10-year coronary heart disease, because that's where our prediction is headed to. And you notice that the variables are, the correlation is so low, or almost nothing. But in between the tables, we notice that there are certain variables that are strongly correlated to each other, like hypertension, to blood pressure, and diabetes, as well as glucose. And of course, on the distribution of the data, 0 represented no heart disease, and 1 represented presence of heart disease. So how did we do our selection? Just to come up with a model and analyze, to come up with a model, that is. We selected our X variables, which we are calling the features. So these were the X, and the Y was the 10-year CHD. That's the outcome. So you can actually see that, you can visualize that in terms of numbers. And as I said, there are certain columns here which are discrete, like education, 4, 2, 1, 3. And you see outcome is 0. It's either 0 or 1, binary kind of data. And that is what now forms our our choice on decision tree classifier. So we went ahead to split into test and train, and I'm sure you can see that, taking 20% as the test size and train 80%. We chose our model, the decision tree classifier, and evaluated our model, which gave us up a 76% score. In my view, this is good. The minimum should be 50%, so 76 really, according to me, is strong. We also did validation and testing just to see how it behaves if I'm to do a prediction, and you can see the model, works accurately and gives output. So what's the conclusion of about the model? So 76% accuracy can be used for prediction. And in my view, more research is necessary on the variables which have strong correlation. I know it's common knowledge out there, but probably more research is just necessary to analyze further details, the intricacies that probably are not yet published, as well as on diabetes and glucose. Our data had a maximum age of 70 years. It would be nice to have an expansive data that goes beyond 70 years, because I'm sure the older people are, the more cautious they are on their lifestyle, and so it would be nice to include such ages just to see how the model would play out and how the outcomes would be. So this model can be used to advise patients on the risk of getting heart disease. When a patient comes to you, you've run the tests, you have the various entries, then once you have those entries, you can use those entries to predict the risk of a patient getting heart disease. And it can also be used to promote more research. Now that there is a research hospital, it can be used by the students to promote more research on the causes of heart